Hello there, Mr. Sutton here, bringing you the Algebra 2 Honors Chapter 8 Quiz Review Solutions on Probability. For this question, we're randomly drawing a marble out of a bag containing all these different types of marbles, and we want the probability of drawing a marble that is not red. So given that there's a few red marbles and a bunch that are not red, it might be just easier to figure out the probability of a red marble and then just subtract that from 1. Use the complement. So how many marbles are there overall in here? We've got 5 plus 9 plus 3 plus 16. So that's 14, 17, 33 total. So the probability of a red marble would be something over 33. Now there's 9 red marbles, so 9 over 33. And then we might as well just reduce that at this point. We can reduce this by 3's to 3 over 11. But now we wanted the probability of not red, so we'll just do 1 minus 3 over 11. And that's going to be 11 over 11 minus 3 over 11, so that is 8/11ths. On this one, we have a two-way table showing the results of a survey asking students whether they play a sport or musical instrument. They want us to make a two-way table that shows the joint and marginal relative frequencies of all this. All right, so in order to make this happen, we're basically going to figure out what all these add up to and then divide all of these by the total to get some percentages. So let's add all these together. 46, 61, 64, and 79. Let me go to Desmos for that because I don't want to mess this up. So we got 46, 61, 64, and 79 getting added together. That's a total of 250. So now we're going to go through and divide each of these by 250, and then we'll also figure out the marginal relative frequencies. So I've set up another kind of table here, but I've left room along the margins horizontally and vertically to get those marginal ones. Just for a point of reference, the joint relative frequencies are just the original 4 here, and we're just dividing all of those by 250, and then we'll add those together to get the marginal frequencies. So let's just go left, right, top to bottom. So we were doing 46 divided by 250. So let me go down here. 46 divided by 250 is 0.184. And then we've got 61 over 250. So let me just change that 46 to a 61. That's 0.244. Next, we'll do 64 divided by 250. So that's going to be, let's see, 0.256. And then we have 79 divided by, you guessed it, 250. And that's 0.316. Now, if you've done this correctly, these all should add up to a grand total of 1. And we'll see that as we do the marginal relative frequencies. So let me do the ones on the right side first here. So we do 0.184 plus 0.244. So 0.184, 0.244, and that comes out to 0.428. And next up, we've got, let's just change that up, 0.256 plus 0.316 is 0.572. And if you do a little quick addition, you should get these to add up to 1. Let's add vertically now. So we've got 0.184 plus 0.256. So 0.184 plus 0.256 comes out to 0.44. And then over here, I'm expecting this to be 0.56, but let's just make sure. 0.244 plus 0.316 is 0.56. And if we add these either horizontally or vertically, either way it should come out to 1. On this problem, the marketing manager of a store surveys people in 3 different cities, and the survey asks whether they would shop at the store. The results are given as joint relative frequencies. It could be given as raw numbers or joint relative frequencies. It actually won't affect our final answer. They want us to now find the probability that a person would say yes, given that they are in city C. Now you got to be careful with the formatting of this language here. They're not just asking for yes and they're in city C. They're saying assuming that they were in city C, what would they say? So it's a conditional probability type of question. We are looking for yes, given that C has already happened. So in order to figure this out, we need to do the probability of yes and C divided by the probability of C. Basically, what percentage of the people who do live in city C actually would say yes. So we're considering this very narrow piece of it here. So we've got yes and C, that's going to be 0.15. And then city C, the probability of living there is just 0.15 plus 0.19. So let's run those numbers on the calculator. So fraction 0.15 over 0.15 plus 0.19 comes out to about 0.441. So there is a 44.1% chance that somebody who lives in city C would say yes and shop at the store. On this problem, we have a bag containing 9 yellow marbles and 5 red marbles. We randomly pick 2 marbles from the bag. What's the probability both are yellow when you do not replace the first marble before selecting the second marble? So we're looking for the probability of yellow and yellow. Since it's an and sort of probability, we need to think about independent versus dependent. Since I'm not putting the marbles back, what I get on the first draw is going to affect what I can get on the second draw. At the very least, it'll affect how many marbles there are to choose from. It also might affect the ones that I'm looking for. So this is a dependent situation, which means our formula we're using, P of A and B, we're going to have P of A times P of B given that A has already happened. So we need conditional probability of B given A. So for our events, A is the yellow the first time around, and B is also yellow. So the probability of that first yellow, we have 9 yellow marbles out of a total of 14, and we can't really reduce that, so we'll just leave that the way it is. Now the probability of a yellow, given that a yellow has already happened, so P given A, since we already picked a yellow the first time around, that means instead of 9, now we're down to 8 yellow marbles that we have to choose from. And we lost 1 marble overall, so this 14 now is reduced to 13. And we're just going to multiply these together, 9/14 times 8 over 13. And if we want, we could reduce this a little bit. So 8 over 14, that can reduce to, let's see here, this could be a 4, this could be a 7. So 9 times 4 would be 36. 7 times 13 would be 91, so 36 over 91 for this one. On this problem, we have some chocolate going on, a box of chocolates with 7 milk chocolates and 5 dark chocolates. 2 of the milk chocolates and 4 of the dark chocolates have peanuts inside. You randomly select and eat a chocolate. Hopefully you don't have any allergies if you're just randomly doing this. Find the probability it is a dark chocolate or has no peanuts inside. All right, so is there any overlap between dark chocolate and no peanuts? They said there was 5 dark chocolates and 4 of those dark chocolates have peanuts. That means 1 doesn't. So there is some overlap between no peanuts and dark chocolates. So this is overlapping. We're going to use the overlapping formula, P of A plus P of B minus P of A and B. Let's let A represent dark chocolate, and let's let B represent no peanuts. So probability of dark chocolate, let's start there. Well, there's 5 dark chocolates out of a total of 12 there if we add those together. So 5/12. Now let's also figure out no peanuts. So they said, let's see, 2 of the milk chocolates and 4 of the dark chocolates have peanuts. That means there's another 6 out of the original 12 that don't have peanuts. So 6 out of 12. And I'm going to leave that as 6 out of 12, not reduce it, because I know I'm going to have to add this together later on with some other fractions. Now let's look at P of A and B. These would be the dark chocolates that have no peanuts. And again, there's 5 dark chocolates and 4 have peanuts, so 1 doesn't. So that's a 1 out of 12 probability that we meet both of these conditions. So putting all that together, we've got 5/12 plus 6/12 minus 1/12. that is 11/12 minus 1/12, which is 10/12. And if we want, we can reduce that to 5/6. For this problem, we have an album with 21 songs, and you make a playlist randomly shuffling the order of the songs. We want the probability that the first 3 songs in the playlist are the first 3 songs listed on the album in any order. So the first thing that's kind of clutch on this is they said any order. So if we're thinking about this in terms of combinations and permutations, any order, the order doesn't matter. So that means we're going to be using combinations. So what we need here then is we need 21 choose 3. That's the setup for this. And for that, we're just going to use the calculator. So here I am on Desmos. To do my combination function, I do n uppercase CR and then parentheses 21 comma 3. Whoops, there we go. That comes out to 1,330. So that's the number of combinations of 3 songs that I could get where the order doesn't matter. Now, out of all these different combinations, there's only one that has these 3 songs in it. So our probability then would be 1 out of 1,330. For this problem, they want us to use the given value of p, which in this case is 5, to find the coefficient of x to the p in the binomial expansion. So, of course, the long way to do this would be to actually expand this whole thing out and then look at the coefficient of x to the 5th and see what it is. A faster way to do this would just be to get that one term. So in order to get that one term, we are going to use this formula here. This is n choose r, and then a to the n minus r, b to the r. This gives us any term of something. N is your highest exponent, and r is just how far away you are from that very first term. So n in this case would be 5, or 8 rather. And then r is, let's see, since we start with the highest exponent and go down from there, that means that r is going to be the n value minus this p value. So if I want to get to the 5th power, that means I need to do 8 minus 5, which is 3. So the x to the 5th power would actually be the 3rd term after the first. So there would actually be that initial term, and then this would be the 3rd after that. All right, so plugging all of this into our formula, we've got 8 choose r, so 8 choose 3. We've got a, which in this case is negative 2x. So we have negative 2x to the n minus r, so negative 2x to the 5th power. And this makes sense if you think about it, because the only way you're going to get an x to the 5th is if you raise this thing to the 5th power. And then we've also got b, which in this case is negative 5, being raised to the r power, so the 3rd power. So the 8 choose 3 part we're going to do on the calculator. So let's do nc capital CR parentheses 8 comma 3, that's 8 choose 3, that's 56. And then negative 2x to the 5th, that's going to be negative 32x to the 5th. And then negative 5 to the 3rd is negative 125. To get the coefficient of x to the 5th, we actually have to simplify this and multiply these things together. So let's do that now. So we've got 56 times negative 32 times negative 125. Comes out to 224,000. So 224,000 x to the 5th is the term, and that means our coefficient is just the number part, 224,000. This one, we want the probability of flipping a coin 30 times and getting exactly 17 heads. So to get this one, we need our binomial formula, probability formula. So n choose r, and then a to the n minus r and b to the r. So in this case, we've got 30 choose 17. And we want the, let's see here, we need the probability of failure, or a success rather, probability of success raised to the number of successes that we want. So if we want heads, we need a 0.5 for the probability, and that's getting raised to the 17th because we want to get exactly 17 heads. And now we multiply this by the probability of failure, which is also 0.5. It's just 1 minus whatever this one was. And that's being raised to the number of failures, 30 minus 17 means we want to fail 13 times exactly. And we'll just plug all this in the calculator now. So plugging all this in, let me clear some things out here. We've got NCR, parentheses 30 comma 17, and we'll multiply that by 0.5 to the 17 and 0.5 to the 13. And that comes out to about 0.112. So about 11.2% chance of getting exactly 17 heads.